Welcome to the Sprint 2 Technology Stack Retrospective for Group 3. We're doing a voiceover slides for this presentation. The presentation structure will go first an overview, then the front end, the back end, and then finally the retrospective discussion. During Sprint 2, we met to determine what technology stacks we would be using for our project. We split up into our ownership roles, and each did research to find a stack that would cover as many of the features requested by the client, while also having each aspect being compatible with one another. We developed two different stacks, each with their own pros and cons, which we believe is as close to the original requests of the client, while maintaining the security of the business's data and keeping costs low. The front-end client for the logistics asset management system using the Azure technology stack will use Azure's app service to build the web and mobile applications. The app service allows us to host web applications and also provides support for mobile applications. The front-end client will be written in a combination of HTML, CSS, and JavaScript, as well as Bootstrap. Bootstrap will be used to handle all the user input, while HTML, CSS, and JavaScript will be used for the design. All the languages used are cross-platform, allowing for both mobile and desktop use. The web app and mobile app backend will be written in Node.JavaScript, which is supported by Azure. We will be using the command line interface offered by Azure, which will be used for monitoring the system status and resources. It will also allow us to use Python for custom scripts and queries and Ajax, which will be used to handle the communication between the front and the back end. The Stack A option database will be implemented as a SQL relational database using Microsoft Azure's hyperscale cloud system. The hyperscale provides capability for real-time access and update on a global scale, accessible by multiple endpoint devices with minimal system latency. The database will include all companies' assets and asset information in relational format. This includes each asset's asset ID, asset description, default location, current location, asset status, status note, and a stock level. The database will be linked to the front-end application, providing all queries and updates to be performed by endpoint devices. The hyperscale system is scalable up to 100 terabytes, allowing logistics plenty of expansion capability without the need to change systems in the future. To ensure the integrity and security of logistics database is automated, backup will be configured with a 7-day full automated system backup with a replicated file storage at a second location, 2. 12-hour differential backup, only data that has been changed within a 12-hour period, 3. 5-minute transaction log backup, 4. The data retention period will be set to 35 days, allowing a full system restore from any point in time with the retention period. This technology is provided by Azure and mitigates any loss of data or system downtime, as all backups are replicated on a second cloud server, allowing for an any point in time database restore. Under the Azure plan, all database servers are always encrypted to protect against cyber threats. The Azure Security Stack is our Stack A for the project design, and ultimately the security stack we have decided to implement for this project. The features offered for Azure Security provided a complete security solution for the cloud services management with key features such as multi-layered security, automated response to threats, live tracking overview of system, 24/7 protection, security CIA triad compliant, RBAC and AD integration, and it is easy to set up and roll out with existing infrastructure. The Azure Security Center gives an overview of the current state of operations and live tracking throughout the organization and cloud service with an easy to navigate UI and surpasses all of the requirements for the client. This slide portrays the detailed Azure security architecture available when the subscription is purchased. This overview shows the complete security interaction and sections that are made possible from Azure, showing that each level of interaction between the containers an option to integrate and implement security control. The front-end client for the logistics asset management system using the Google Cloud Developer Stack will use the Google App Engine and will be written in Python. Google offers many features in the Google App Engine that we can use instead of needing to develop the underlying infrastructure ourselves. The front end will be written in HTML and CSS for the design and to create a static web page allowing access wherever there is internet connection. The front-end client will have the ability to accept uploads of files containing any updated asset information, which can then be sent through the app to the administrators for verification and entry. The communication between both front and back end will be handled with Ajax. Google offers a command line interface which can be used to monitor the system resources, status, and other information that may be required. The command line also allows us to write any custom scripts that may be needed using the Python language. Okay, this is the UI sketch, the user interface sketch. This is the actual sketch itself. It's relatively rudimentary. I will go into more details on the actual breakdown of it and what it represents on the next page in more detail. This is just to give you an idea of what the actual sketch looks like itself. The user interface design is fairly basic. There's a banner and logo left blank so that the customer can fill them in with whatever they desire. The sketch itself is designed to be very, very basic, with the next step being a wire mockup, which is essentially a digital representation of what the app would actually look like on a computer. So this is just basically gives a simple idea of what sort of components and what sort of layout will the app will ultimately have. The Stack B option for the database will be to use Google Cloud SQL Relational Database, providing a secure and easy-to-use database solution with easily accessible data for endpoint devices. However, Google Cloud lacks real-time update capability on a global scale and will require additional admin services to keep up to date. The database is scalable up to 10 terabytes, allowing for easy expansion of the system. And to ensure data integrity and protection against cyber threats, data is encrypted when on Google servers, and back automation will be implemented to full patch and update actions which can be customized to meet the needs of the client. Google also provides replicated files of the database to guarantee that full system backs are available even if the primary hosting server goes down. For our Security Stack B, we have chosen Google Cloud Services Security Command. This will integrate with the rest of Stack B. With the Google Stack, we can see many of the same functions as Azure, however this is a highly customizable option, and the initial setup is quite in-depth and complex. This is very beneficial for environments with specific setups requiring a very specific set of skills. Though all the requirements can be achieved with the Google Security Stack, the complex setup and shortage of skill falls this option short. It is, however, the cheapest option, which is beneficial where cost is a concern. This is a simple database design schema designed to give an overview of how the database fits together within the cloud server between the replication cloud backup to the front-end device, which we would be implementing under our recommended stack. The risk and threat matrix with any cloud-hosted applications are due largely to the fact that they are, for the consumer, 100% online and rely on network and internet connection to enable the services. Some of the most common risks are data breaches, human error, which is believed to account for around 95% of cloud security failures, insider threats, DDoS attacks, which result in lengthy service outages, reputational damage, and exposure of customer data, insecure APIs, as APIs are commonly the initial entry point for attackers, account hijacking, which is probably the most vicious type of attack, which is where an attacker uses stolen credentials to gain access to critical areas of cloud services, compromising the confidentiality, integrity, and availability of the data. There are many more risks involved in the cloud services environment, but none so different than any existing risks. It just changes the attack vector. By use of the Azure Security Center correctly configured, most of these threats can be mitigated and contained before any real damage is done. We've carried out a detailed SWOT analysis on each stack. We structured these towards the companies and services as a whole, and some features of how it would best benefit the client's requirements. Azure shows much more of a promising platform for this project. While both Google and Microsoft provide excellent potential solutions for logistics systems, after comparing the technology provided by both stacks and running a SWOT analysis, we have determined that the Azure stack provides a complete package which integrates the logistics existing Microsoft resources, requires little additional training to system admins, extensive documentation including setup and best practices, and real-time database and updates from front-end services. The Google stack, although powerful, has some negatives which we do not see from Azure, including a lack of real-time updates from front-end devices and the Google system. It will require extra training and system implementation for logistics admin. There's a lack of extensive documentation for enterprise solutions, and it will require a hybrid setup to integrate logistics current systems. It is these fundamental differences between the stacks that led us to recommend Logistics to use Azure for their system. A few things that worked well for the group during Sprint 2 were the ability to draw upon team expertise when it came to the more technical aspects. Not all team members had equal level of technical knowledge, but those who had a better understanding were more than happy to clarify and provide direction in order for all sections of the task to be completed to a high standard. The next good aspect of the sprint was the input provided by the high distinction students who were able to guide the sprint using their expertise. This was a great help to the group overall as it made sure that we stayed on the right path to achieving our outcomes. The final item that we thought worked well with this sprint was the communication using voice over IP through Discord. By using this tool, we were able to have more effective conversations in real time, allocate our work more effectively, and address issues head on in order to clarify as a group. A few things, however, that didn't work so well: shorter deadlines due to the encroaching end of semester. While the group spent a couple of weeks on the first sprint, we realized we didn't have as much time for the second, due to the end of term. This put a bit more pressure on the group to complete the task faster. On the topic of deadlines, another issue faced was conflicting deadlines with other subjects, which meant that some group members weren't able to be as involved as they had been in the first sprint, which in turn meant that all team members began to feel a bit more pressure to get the task done on time. The final issue faced during the sprint was initial confusion over the sections of the technology stack which required which information and specifically how much detail was required to be provided. The next stage of the project is the project handover. During this stage, all project documentation and communication will need to be compiled into a report to present to the coordinator. For this task, we will try to allocate sections to the group early on so that they can work around their other deadlines. We will also schedule the final Scrum meeting earlier than normal so we can discuss any issues and encourage group members to let us know as soon as possible if they are going to be able to deliver their sections or if we should reallocate the work. The final recommendations and advice that Group 3 would like to pass on would be to A. Plan ahead. Don't just plan for the first upcoming deadline, but create a schedule that takes into account all upcoming deadlines. This will ensure that all tasks have equal time spent on them. B. Group work should be allocated based on ability and capacity, not just to ensure equality. Not all group members are going for the same grade, nor do they have the same level of capacity to take on a similar workload. C. Grade reviews should be discussed as a group to encourage increased participation, address lack of participation, to ensure everyone is marked according to their contribution fairly and has the opportunity to dispute a mark if they would like. And finally, team communication is key to project success. Whilst Group 3 did struggle to communicate at times, because we persisted, we have managed to successfully complete the work with little to no conflict and produce a high quality output.